Hello, everybody. Welcome back to Archaeology with Flint. And I'm here with a very special guest, Dr. Jessica Cook Hale, who is an underwater archaeologist who specifically focuses on Stone Age archaeology. So we're going to talk a bit about underwater archaeology of the Stone Age. We're all to some degree familiar with underwater archaeology. This stuff makes the media all the time, shipwrecks or lost. Well, more shipwrecks, of course. This is what I'm familiar with from the Mediterranean, all these Roman shipwrecks, of course. And then even sort of lost cities like Pavlopetri in the Aegean, where archaeologists are mapping out the architecture that's still preserved underwater. But what we're less familiar with is Stone Age archaeology underwater. People sort of think that it's not findable, it's not doable, but the reality is that it is. And so I'm joined here by Jessica Cook Hale of Bradford University. I'm really, really glad to have you here. Do you want to tell us a bit about yourself and how you got into this kind of niche?
Sure. Thank you, first of all, Flint, for having me. I'm really, really pleased to be able to share this with you and your audience today. I obviously wouldn't do this if I didn't find it particularly fascinating, but I do think that there's some interesting lessons that we can learn from looking at Stone Age archaeology out on the continental shelf. And admittedly, it's a bit more difficult, but I think it's pretty rewarding for that. Just to give you basic background, I was trained at the University of Georgia for all of my degrees
Okay.
and trained under Dr. Irvin Garrison, who is a geoarchaeologist that holds a joint appointment in the anthropology department as well as geology. So my master's is an MS in geology, and that
Wow.
is the time period during which I began first working on these kinds of projects. People ask me, and I just tell them it kind of seemed like a good idea at the time. I mean, I grew up going to the coast, onto the Georgia coast. Have some of my earliest memories are from Cumberland Island. Have always loved the sea. But the idea of going out and looking at materials that were not shipwrecks, I found pretty fascinating once Professor Garrison began explaining the work that he was doing at Grays Reef National Marine Sanctuary at the time. He sent me a link to sign up for certification classes. I did it. I took all the additional training needed to be a scientific diver. It's pretty extensive. Did additional diving to bring my dive resume up to speed. And the next thing I know, I'm on a boat headed to the marine sanctuary with all these NOAA divers in Garrison. They're saying I have to back roll off the boat. I've never done this. It's my birthday and I am terrified.
So you
uh,
did your first dive with them on your birthday.
yes, I spent my birthday on the bottom of the Atlantic. I truly did. So while I've done quite a bit of work doing dive operations, we do quite a bit of work using remote sensing and other methods that do not require we put on life support equipment. And that is actually us headed out on a dive in the Atlantic.
Okay.
And the image that you just showed right after is us on the bottom of the Gulf of Mexico,
Uh-huh.
doing setting in a datum point, actually. So a lot of the work that we do, it's not necessarily photogenic, right? It's the grunt work, but this is what we do in archaeology so that we can make the interpretation so that we can do the spatial control, right? It's not pretty, it doesn't look neat on photographs, but it's absolutely critical.
It looks essential to me. I mean, so a part of the reason I showed this is you labeled this photo as Barracuda. Is there a Barracuda here?
Oh yeah. Well, that you see some interesting wildlife. The barracuda don't bother me. They don't ever
Okay.
really mess with you. They sort of stare at you, but ask me about remoras another time. I have a
Oh
thing.
no.
They're absolutely irritating and they're pests. So
Okay. So all right, we're thinking about Stone Age stuff. Just very recently in the press, there was this Stone Age megalithic wall that was found, I guess, off the coast of Germany in the Baltic Sea. What do you think about this find? Is this really the oldest megastructure ever found?
well, it is a bit of hyperbole to some extent, but that's what you have to write when you write newspaper headlines, I suppose. But it is a very large structure. It's almost a kilometer long.
Yeah, it's impressive.
It's very old. I think it points up the fact that human beings were manipulating their landscape very, very early. So it's a really important find. Really, really pleased to see this get the attention it deserves. And I was also pleased to see that when it did hit the press, that many of the publications also looped back to the fact that there are smaller examples of this in North America, in Lake Huron, the Drop 45 site, examined by
Ah.
John O'Shea, Ashley Limke, and Lisa Sonnenberg. So there is a commonality to this as well, right? It's not just the people in the Baltic that were building these megastructures.
Mm-hmm, mm-hmm. And were those also for hunting then, the ones in Lake Huron?
They
Interesting. So the
were,
channel
and
game.
Yes, they were channeling reindeer, which apparently are very dumb animals. And then the structures in Lake Huron have hunting blinds, and some of the sediments that have been examined yielded a piece of obsidian
Hmm.
dating to around 9,000 that was chemically traced back to the West Coast. So, I think this points up the sophistication that was going on both sides of the Atlantic very, very early on landscapes that now are a little bit more difficult to access than they used to be.
Yeah, I think this is something that people need to recognize is that a lot of the newer archaeological finds from hunter-gatherer communities show just how sophisticated and complex they are. Building architecture like this, or even ritual architecture in some cases, and mounds and pillars and everything you could think of. And then at the same time, this kind of functional architecture that's very clever and has a very practical use for hunting. And then, as you mentioned, the trade in objects over long distance even, or at least the carrying of objects over long distance.
Right.
Yeah, but this is not the kind of stuff you find. You're finding more things like stone tools and other stuff like that. Some of these are phenomenal, by the way. This biface is absolutely lovely.
I did not find that biface. That was recovered in salver expeditions on the east coast of Florida back in I want to say the 70s.
Okay.
But I did get to geochemically analyze it in a non-destructive manner. You'll
Hmm.
notice that it's pretty patinaed, it's pretty beat up, but
Yeah.
that dark stain, it's very unique to these materials that come out of these sites. The other stone tools, again, I didn't recover those personally. They came out of work in 1986 at Ray Hall Springs. That is a site in the Gulf of Mexico that's in approximately 15 meters of water. It was a spring site and was intensively excavated by actually Garrison and Dunbar and Fought and a number of other people from MMS, now Boehm and Bessie. At the time, the materials were considered highly equivocal that come out of these contexts that are so beat up, so corroded. It takes a fair amount of analysis before we satisfy ourselves that they were probably crafted by people.
Yeah, I mean, because with the corrosion and the encrustation in particular, it does make it tough at times to find a platform or a bulb of percussion. I mean, with this biface, you can see that more clearly, I think. But
Mhm.
yeah, that crescent one, being named Flint, I've seen a lot of stone tools. That one I'm not sure of just from looking at it at the picture of it.
Yeah,
Um,
we would
but
call it equivocal.
yeah, but some of these others are definite tools, I mean, without a doubt. Let's
Mhm.
see. And then at the same time, you've uncovered sort of flint knapping actual locations where they're quarrying and manufacturing stone tools. So here we're
Mhm.
looking at what you call it a debitage scatter, yeah? I think
Yeah,
I remember seeing.
it's a thin scatter.
Mhm.
We probably only went out about 15 meters from the drop point, and we recovered that piece and one other piece next to rocky outcrops.
Okay.
But this is really common in Appalachia Bay, on the Oscilla Paleo Channel and other paleo channels. The bedrock is very close to the surface. It's really ideal circumstances to see the material now for sites to actually be preserved on the seabed and accessible. You do have to hand fan away a little bit of the sediment, but the stuff tends to pop right out. Yeah, some of the prettiest patch reef I've seen in a long time, too.
Is that you?
Yes. I'm also very suspicious of all that shell scatter out there. We need to go back to that locale. We were focusing on simply determining whether there were anthropogenic, human modified materials present.
Mm-hmm.
Um, and we satisfied ourselves that that was the case. But if you look through some of these frames, you'll notice that the shell scatter varies in density. And we do
Yeah.
know that while shell midden can preserve, um, that doesn't mean all shell deposits preserve alike. And we could be looking at lag that might have originally been deposited as part of subsistence activities.
Okay. And this is the hand fanning coming up.
Right. That was a very satisfying dive because of the materials that we recovered. That we
Mm-hmm.
did not need to determine that there was much out there. We just had to demonstrate to our satisfaction it was. But then, in addition to pulling out that flake and other materials, we also found that piece of cypress.
There we go.
Unfortunately, we tend to wear black gloves. So when you pick up a piece of black stained debitage, there it is. Um, there's some contrast problems in the underwater lighting.
No, it looks great though. That's you know, it's funny. So this is basically the equivalent of like a survey. You're going down there to see what you see in different areas, and we'll talk in a bit about how you target those areas. So let's go to the site that you've published in more detail, the Econfina. It's in the same area as Osceola, where we just were off the coast of Florida in the Gulf of Mexico,
That's
right?
right.
And so
Yes.
this just gives everybody some locations on how far off the coast it is. And then the dotted red line is the shoreline from 5,500 years ago.
Give or take. Yeah.
Yeah, ish. So here's another nice lithic that you found. This is again in a quarry zone. So this is a quarry zone in the sense that there's chert and flint outcrops for people, and they were extracting material from them, right?
Right. One of the questions we wanted to ask and answer is the lithic assemblage at this quarry outcrop area, is
Right
it
here.
substantially different than the materials that came out of that shell midden? And the answer to that is yes. We did a lot of math and we seeded a lot of sediments to determine that. This is a blade core that I particularly love because I was playing with it in the lab after it had been collected, and I found a blade that had come out of the midden. And Garrison looked at me and he said, "You're not that lucky." And I said, "Watch."
Wait. You're saying so you
So
have a blade from one site from the shell midden that we'll get to in a second, and then the blade core from the quarry, and it refit.
it refit from 50 meters away. So now we've got a human activity.
That's super, super, super cool.
Those
Yeah,
are the moments.
that is absolutely phenomenal. So let's show everybody this shell middens. So this here is people extracting stone material and then actually napping the stones. And then 50 meters, 100 meters away are these shell middens that you've published in a few different articles. In a sense, a huge accumulation of shells that are a byproduct from feasting or something like that. And so here's some of these shells here.
You really can't fall off a boat out there and not bump into one of these, it seems like to us. I mean, Econfina Channel site was considered to be sort of the premier mid-Holocene shell deposit out there. But now that we've started to expand our surveys, we keep running into it. So I couldn't begin to tell you at this point quantitatively what that distribution really looks like. But there's a lot of it. It's densely occupied.
It's great because you're getting, I mean, look, I'm a zooarchaeologist, so shell midden's like, all right, this is primo. We're getting a sense of what part of the subsistence base and then the intentional accumulation after consuming this food in a sense. There's lots of different reasons why people might have accumulated shells into such a large midden, but they're left behind as features in the landscape. But for all the skeptics out there, they're saying, wait a second, shellfish live in the sea anyway. So how do you
Yep.
determine a shell mound created by humans that's found underwater from the Stone Age versus just a natural accumulation of shells itself? What are you doing there? I'm guessing this is where your geological background comes in play.
It very much does. And if the skeptics are asking that question, then they couldn't possibly ask it any more critically than we ask ourselves that as soon as we encounter one of these deposits, right? Because as you note, there are tons of natural reefs out there. The first part is we look at how the midden or the potential midden, what do the components look like? At a macro level. So, do we have a lot of disarticulated halves of oysters or other species? We usually see oysters in the Gulf, but other shell middens have different taxa. We look at that. We take bulk samples of the materials. We sieve them. We look for things that should not be there.
Okay.
For example, charcoal,
Hmm.
stone tool fragments, right? We call it microdebitage, but sometimes you find even bigger pieces.
Hmm.
Burned oyster. It's pretty hard to light an oyster on fire underwater. It takes a fair amount of commitment. So we feel pretty comfortable when we see signs of burning that people may have been responsible. We cannot rule out that a shell deposit left behind by people could have been hit by a wildfire, right?
Yeah.
So the memoirs of Cabeza de Vaca, one of the first Spanish to come into this area, note that there were a lot of lightning strikes in these forests.
Huh.
And
That would still need to be deposited by humans on ground, not in the
yeah,
sea, and then
correct.
it would need to be subjected to a forest fire. So it's still
Right.
anthropogenic in that sense. Yeah.
Yeah, right. It's still been removed from its natural situation. There
Yeah.
are certain types of snails in the region that like to munch on midden.
Hmm.
So we look for those.
Okay.
And we look if there's any evidence of faunal bone that's terrestrial.
Hmm. Hmm.
And this is actually pretty well understood. because people like Gagliano and Pearson back in the 70s and 80s were doing these wonderful studies for National Park Service where they were taking cores and bulk samples on known sites of
Hmm.
different types, on different types of landforms, and then comparing them directly to offsite materials that they were sure were not archaeological. And they were treating these materials, these archaeological materials, as a specific type of sediment. And they use the term bioclastic. And I think it's brilliant.
Uh-huh.
You can't get this stuff without people interdigitating with their environment. So it's back to that, right? One of these things is not like the other. This stuff shouldn't be here.
And so
And if
that's where
it's
you're taking cores and then analyzing it under microscopes, even to sort of, I think the way you put it in your article, at least one of them, was that the sediments themselves are heterogeneously mixed, while if they were sort of mixed together for natural reasons, they'd be well sorted or they'd be oriented or something like this. If it's humans
right,
just throwing stuff together, it's going to be very heterogeneous and have all these different components to it, as you illustrate sort of here, charred plant material,
right.
microdebitage, etc. It's not an easy job, is it?
Well, I mean, it is really satisfying. I mean, you got the dive pictures, right? And that seems
Mhm.
like it's the glamorous side of the job, although uh, it sometimes has its moments too. But the real satisfaction is when you spend that degree of energy and effort to recover these materials, take them back to the lab, and then you can pull these kinds of threads out of it, right? So I'd say both activities are satisfying in different ways, but the diving's useless if we can't verify it in the lab.
Yeah, I mean, look, a chance find that one flake is great, but it's the pattern that you put together that tells the larger story. And so it's about figuring out how to figure out what the pattern is and then come up with
Hmm.
some possible explanations for it, and other people will come up with other explanations for it and things like that. Yeah,
Yeah, it's a scientific method. You make your observation, you form your hypothesis, and you test it.
yeah,
Wash, rinse, repeat.
yeah, it makes
Sorry, no
perfect
pun
sense.
intended.
Okay, so this is actually phenomenal. So you have found areas where Stone Age hunter-gatherers, from 5,000, 6,000 years ago, are quarrying for stone tools and working them in location. They're feasting on shells and leaving behind intentionally these shell middens. But this stuff
Hmm.
is so ephemeral. How do you actually go about finding it? It can't be that easy to find. Is this just sort of chance finds? How are you able to actually focus your research on this sort of material?
It's a combination. The reality is that the archaeological community in the regions that I've worked has really benefited from local knowledge.
Hmm.
In Florida, in particular, is one of the first areas to adopt scuba technology as an activity, and the Florida river divers were starting to pull out Pleistocene materials from the rivers in northern Florida, as well as the sink features in the peninsula as early as the 50s, right? And that's not even getting into the work that was done at Waukulla Springs in the 30s in the 19th century. So that local knowledge has already established there's stuff out there. And then the question becomes, okay, how do we systematically target it? Because boat time's expensive
Hmm.
and tank rental is not cheap either. So that's where mapping the seabed comes in. And we do a lot of predictive modeling with all the caveats around the potential flaws in it. So we don't just do random dives. We go back, as you say here, from the known to the unknown. We look at terrestrial patterns. We look at cultural types, right? So periods where people were using shellfish as a subsistence base. It's really important to look at those sites on land and say, what are the factors, right? What environmental patterns or cultural patterns can we tease out of these larger distributions? And then we project it offshore. And if we're fortunate, then after we pull all those threads together, this is what we get. And the
Yeah.
remote sensing is really key. It really is, because there's no point in hopping off a boat unless you know that you're near a feature that would have been high likelihood.
So in a sense, what I'm gathering from this is there's a whole lot of library work that goes into play, or computer work, and you're
Yeah.
sort of combining what you already know from on land archaeology with geological surveys underwater to find regions where there's going to be sort of exposed sediments from this period, in a sense, those paleo channels, right?
Yeah, it's got to be testable. And there is a real irony to the preservation here, right? So if it's at the seabed,
Hmm.
you can lay hands on it, hypothetically. But
Okay.
if it's at the seabed, it's subject to marine forces.
Hmm. Hmm.
And and may or may not have sat in the wave zone during submergence. And that's really important to understand the rapidity with which the wave zone might have passed a location, because the
Okay.
longer a locale sits in the wave zone, the more destructive forces it experiences. The wave zone is the very worst thing for a site.
So what you're saying is that rapid changes in the coastline are actually good. They help preserve archaeology for archaeologists to
Mhm,
find, while a more
mhm.
slow change where the wave zone's going to persist for a while in different locations is actually going to destroy this kind of evidence.
That's absolutely correct.
Okay.
Um, Now, the other side of this is if you're in an area where you've got a lot of sedimentation, like
Hmm.
Appalachia Bay in the Gulf of Mexico has virtually none on that side of the bay. So there's not a lot of dirt getting dumped on top of these sites, right, to bury them. If you move to the west side of that bay, out towards Ochlockley Shoals, or further west along the Panhandle, where you've got more material coming in from the Apalachicola River,
Okay.
sites get buried. And then you have to test them a different way if that's the route you want to go. And that's what we do a lot of in the North Sea.
So you're thinking in that case, you'd actually need to do more coring and do more investigation under the whatever sediment has accumulated. Um,
Yeah, you got to target it with some kind of coring mechanism. It's not practicable to put a diver in an excavation unit that's 4 meters deep. It's not safe, and I'm not even sure we have the engineering to do it yet.
yeah, it's actually funny how that's the opposite of sort of terrestrial archaeology, sort of on the ground. The more rapid deposition over something, the better preservation you're going to find. But underwater, it's just impossible to excavate away a meter, 2 meters, 3 meters of sediment. Yeah.
Yeah, it's a persistent problem.
But it would at the same time, of course, still preserve the stuff under that. You don't want it to be highly erosive either, or it's going to have disappeared, right? And so,
Well, that's
yeah.
right. Yeah, the deeply buried stuff on fluvial terraces and whatnot. It can have outstanding preservation, stunning preservation. The question is how you get to it.
Yeah, yeah. This is actually really, really freaking cool. Okay, so you do all this work to put together these models of what underwater looks like, where you could predict there to be sites based on the geology and the archaeology that we have, so known to unknown. But then you actually have to go test this stuff. So walk me through how you would go and actually test this. How do you plan out what you recover? What's different from you doing this versus just me going and diving with friends, let's say? Not that I would ever go and dive in places like this, but that idea, what's different?
Well, we have to obviously have locales that we want to target, right? So we pull from our remote sensing data and from our predictive models locations that we think would be worth having a proper look at.
Hmm.
And it kind of proceeds similar to phase one work, but not well in phase one and phase two in the US, right? The way CRM does this with shovel testing and
Hmm.
then block excavation. So our equivalent of a shovel test is this sort of thing here, where we drop to the bottom of a downline that's been thrown out off the boat at GPS coordinates of a location we want to test. And then we tie off a real line because water visibility can be variable.
Hmm.
Sometimes it's been less than a meter out there, and sometimes it's 5 or 10. You've got to maintain some way back, right? And so you take that reel and you go out at 5, 10, 15, and 20 and 25-meter spacings, and you do what we call a circle search. You
Okay.
just swim in a circle and you
Yeah.
hand fan sediments. What do you see? Do we see any suspicious shell deposits? Do we see any lithics? Um, is it a bunch of eelgrass and we can't tell anything? And it's almost a bounce dive. It takes a little bit longer than a bounce dive, but it is really kind of jump in, have a look, jump back out. Is this worth sticking around, or do we need to move to the next target? Now, if you
Okay.
do find material, then you can put in block excavations. I've done that. It's easier when the sediment's more competent. Your walls will never be, I mean, I'm sorry, but the walls of the units I've put in at Econfina are just would horrify a terrestrial archaeologist. There's only so much control you can exercise, right, in
Yeah.
3 meters of water. Um, but you can sample that way. But I'm getting to a point, Flint, with these sites where I want to test them in as minimally invasive manner as I possibly can,
Hmm.
because the technology continues to develop. I want to leave a lot still out there that's untouched. So
Yeah.
we might take a sediment sample, or we might sample one or two lithics, and we might map it, and then we may just move on and report the site,
That
to
makes
the
sense.
to the state master site files. Yeah.
And I'm guessing this is you taking it, or not you, but one of your dive colleagues taking a core?
Yeah, Matt Newton, University of Florida. If you want to look dignified, this is the wrong field to go into. Matt looks remarkably dignified. Most of the time, we look like absolute idiots when we take these courses, but got to get the job done.
Yeah. So wait a second. Let's go back to that map really quickly. You say these are all known sites, so these are all sites that you have actually, or you and others have surveyed, and some of which you've actually excavated and cored, in a
Correct.
sense. And so, but all of them have been at least hand fanned and had some surface collection taken from them.
Correct.
Absolutely, really, really
Correct.
cool. And then how do you?
Morgan Smith, UTC Chattanooga, is doing a lot of this work right now too.
Okay, and then you get the age of them from radiocarbon dating bone or charcoal, stuff like that.
If possible, and sometimes if diagnostic artifacts come out, then that makes
Yeah.
it reasonable to say, oh, this is a Bolin point, this is early Holocene. That usually doesn't happen to me. So
Mm-hmm.
I usually get what we call the expedient tools or the informal tools, because by the middle Holocene, people were moving away from the very formal types that they used in earlier periods.
Mm-hmm.
But radiocarbon dating shell is problematic, but we do have the
Yeah.
correction algorithms for that region now. So
Oh, great.
you date whatever you can. Yeah.
Yeah, exactly. So all those dots on the map, let's say, are they being accumulated, those sites, over a range of time, or are they mostly dated to one period?
The Osceola River has some of the densest terminal Pleistocene and early Holocene occupations in the American Southeast. We're
Okay.
definitely in Florida.
End of the Ice Age, start of the warmer period, the Younger Dryas included, and then after the
Yep,
Younger Dryas is what you're talking about.
that's right.
Okay.
One of those factors that may have led to that identification of it as a hotspot for end of Ice Age, early Holocene activity is the fact that a lot of the initial surveys out there were not very interested in anything later than about 8,000. And
Okay.
that's fine. That was not the point. Point of those initial surveys in the 80s and 90s was to see if they could find terminal Pleistocene sinkhole sites with good preservation, right? So this points up something that if you don't look for something, you may not find it.
Yeah, for sure, which is where predictive modeling has its issues.
Yeah.
Yeah. But at the same time, this is
So
actually pretty fascinating. So some of these sites are from the period that we think of as Clovis period. It might not be called that in this region. I'm not a North American archaeologist, but so they're sort of that period and then after that period, and then you're getting underwater material from those periods as well, which is absolutely remarkable. I guess it makes sense you mentioned that rapid sea level rise actually helps preservation. And so that's a period of rapid sea level rise. And so shell mounds and lithic scatters have a better chance of surviving on the surface as opposed to being subjected to waves.
well, one of the factors of this region that makes it very attractive to doing this kind of work is the fact that that continental shelf is an extremely low gradient.
Mm-hmm.
So I should note that the sites we're working on are very easy to work on because they're all in less than 10 meters of water. And they
Okay.
were all terrestrial up until about, 8 to 5,000 years ago. And I'm giving a very broad range there because nailing down that sea level curve after about 6 or 7,000 is tough.
Yeah.
But the point is that even though the very early sites would not have been drowned up until what we call the middle Holocene about 5 or 6,000 years ago, when the sea level does rise out there, even if it's a small amount, it floods a lot of landscape.
Yeah.
And this is critical when I'm thinking about interpreting these coastal sites,
Mm-hmm.
because there's always been an argument made that people didn't start using coastal resources until the shoreline became more stable. And it's true that sea level did slow down after about 8,000 years ago. But one area where even a small increment of sea level rise would still have drowned a lot of area would have
It's
been
right
this
here.
region, and yet people were still using the coastal resources, which really raises some questions about human resilience, inventiveness, persistence, tradition, all of these different threads that we try to pull as archaeologists, right? Because we really are trying to understand past cultures, not just
Yeah.
the stuff behind.
No, I think that's really fascinating. I mean, it shows that even though it's tough to find, you have to do these kind of dives. We do have clear evidence that hunter-gatherer people from that period were very intensively exploiting coastal niches in a sense. Yeah, I think that's absolutely important, and that shows how this kind of research really fills in the picture from more traditional land-based sort of archaeology. So yeah, that's really cool.
Yeah, we really want to interdigitate and need to interdigitate with the rest of our, professional colleagues, right? And understanding these landscapes as a holistic thing and not, as Jesse Halligan says, above and below the waterline. It's an opportunity, not a challenge.
Yeah, that makes sense. Okay, so since I have to have some conversations about pseudo-archaeology right from this period, I guess I have a question for you. Could this methods be used to find Atlantis? This is a reconstruction of Atlantis made by my partner with photographs that we've taken from Athens and Rome and made on, is this what these sites look like from the end of the Ice Age?
Absolutely not. Um, and the fact is that we have sufficiently sophisticated remote sensing methods, everything from side scan sonar, multi-beam echo sounder, magnetometry underwater, right? We call it transverse gradiometer. We can do seismic studies that image the seabed and things below it. Some of the ultra high resolution seismic that's used offshore on the East Coast in the US right now for wind farm commercial work
Hmm.
can image 30, 50, 100 meters below the seabed at pretty high resolution. Some of the parametric sub-bottom stuff can resolve items as smaller than 50 centimeters. So there's an awful lot of continental shelf that's being surveyed for commercial purposes and has been for decades. And if those kinds of structures were out there, they would have stood out and somebody would already know about it.
Yeah, that's how I see it. I mean, from my area of the world, Greece, we have people doing this, right? We have teams going out and surveying and excavating underwater sort of cities and settlements, including, for example, the Helike project, which many people think was the inspiration for Plato's Atlantis to begin with. It was submerged right before the story was written down. So we have this kind of surveys going on, as well as shipwrecks, of course. And just to give people a sense of the scale, this is the Oxford database of known shipwrecks from ancient and medieval times, right? There's 1,810 of them in the Mediterranean. It's not like some small amount of underwater archaeology has been done. This has been something that's been ongoing for decades, by very skilled people with very competent methods and techniques. And then you have like these fantastic finds from Thonis Heraklion off the coast of Egypt, where, this port city, I was reading this article yesterday, 70 shipwrecks have been found. 70, seven
It's
zero,
incredible.
in this one
Yeah.
site, and they can put together whole ships because wood preserves. That this kind of stuff would be visible, especially because we have people that are actually targeting, like you and others, your colleagues at Bradford as well, in Doggerland and,
Mhm.
and, and elsewhere, that are targeting sort of Stone Age, terminal Pleistocene, end of the Ice Age, start of the Holocene, Younger Dryas type periods underwater. And so we are finding
Yeah.
materials. Yeah.
Yeah, there is material, right? It's not that it's not that we haven't looked. And I think we've covered, the preservation challenges that we can experience pretty well. We haven't talked as much about the marine geophysics, although that is a huge part of what we do. I mean, I like to look at predictive modeling and things like that, but ultimately, I can do all the predictive models using mapping software all day long, and it means nothing
Hmm.
if I can't take the marine geophysics and understand the seabed and that which it lies below it, because things like river channels get infilled over time. So these marine geophysical methods are well understood, although the technology always continues to advance. They are well deployed. It is not necessarily easy to do, but it is done. And there's a tremendous amount of commercial work doing it as well. So, cultural resource management in paleo landscapes is a done thing in North America and in Europe. Wessex here in the UK understands it really, really well. I'm pretty sure if we ran across classical buildings or large monumental architecture,
Pyramids.
well, I mean, we kind of did. I mean, the Germans have found the Blinkerwall. I mean, that's monumental
Yeah.
architecture.
Yeah.
You know?
It makes sense. And I mean, like you said, there's other examples from North America that people have found, like in Lake Huron and stuff. And so people are finding this stuff and it's there. One of the things that always wows me as a land-based archaeologist, I mean, look, I work downhill from this thing, in the Agorad.
That's not a bad
So
job.
there's some decent preservation, but you guys find like wood, Let me find the video of you and your dive partner pulling up a piece of cypress, and you can talk about some of the positives of preservation. So here you are, still at the Ostilla Paleo channel.
Mm-hmm. This is in the same location where he found that small flake, and that's,
Okay.
was in his hands. So it was very close by. And this was one of the most exciting aspects to the dives that day, actually. Um, because when you run across something like this, I mean, obviously you can date pieces of wood with radiocarbon, So that's helpful. But this was well enough preserved that we were able to determine what species of tree it came from. And I should note that I am a geology person, right? Most of my training is very geologically oriented. I am very bad at living things or things that used to be living. I'm terrible at bones, as I always say, and plants. But the fact that I was able to pick this up and think to myself while we were in the water, I think this is probably cypress,
Huh.
tells you how good that preservation is. And it tells me immediately what that environment was. I don't know if it's contemporary with that lithic flake. Maybe, maybe not. I mean, that is a deflated sand sheet out there, right? So you don't have a lot of stratigraphy to help you with those questions. But I know at the time period that wood was dropped on that landscape, that it was quiet water, subtropical environment, kind of a back swamp.
Fantastic. I mean, it's just like from my perspective, it's just amazing because you know, I've worked on projects that are near waterlogged sites in northern Greece, and I mean, you get like leaves and you get stems of plants, you get the wooden posts that houses on the lakeshore are built on, and it's
Mhm.
just it's such a different level than what you get on land. And I mean, it's one of these things that people think that, oh, it's underwater, it's therefore impossible to find. When from my perspective, it's like, actually, there's much more to find underwater because it preserves a different kind of material that gives us a different perspective on these people in the past. Um,
Well,
yeah.
that's exactly right. I think I mentioned when we were emailing a bit that 90% of all of the worked mammoth and mastodon ivory, okay,
Hmm.
pieces of ivory from the end of the Ice Age that were not simply found at a site but had been carved and manipulated by human beings. 90% of that's come out of the Osceola River. And my good friend and colleague, Dr. Andy Hemmings, is the one that did most of those excavations. 90%, one
Wow.
location. And that's because of that preservation, which tells you carving that material must have been a very common activity.
Yeah, it tells
So,
you what you're missing on land because it's available to find underwater. This kind of worked mastodon ivory is just, it's splendid. And then just another example I came across recently in my own research is this shipwreck, the Bouferrer shipwreck off of Sardinia. I mean, they were able to find grapevine shoots that the amphora were packed in to make sure they would not roll around and stuff like that. You can't get that on land. It's phenomenal to think that it's not just the wood that's preserving, it's the fragile shoots from grapevines. And so it's just
yeah.
something that, you know, people need to recognize that because material is underwater, certain components of it are far better preserved. And in many ways, as you've mentioned, they're far better mapped even than above ground stuff or underground stuff because of all this commercial work. Do you work with commercial firms like oil companies and other things like that? How do you get access to that data?
That is a wonderful question. On the North American side, I have done commercial work, and the answer is you don't get access to the data because it's proprietary unless you are the consulting archaeologist group that's been hired to work with these development companies on these projects. Although that having been said, I think it was Shell, if I'm not mistaken, a colleague told me donated a bunch of marine remote sensing data to Texas A&M's oceanography department years ago to train their geology students in sequence stratigraphy. So there is contact and conversation between the development companies and academia. It's just a matter of finding places that want to take it. Here in the UK, and I should mention that one of the things that I really enjoy about the work I'm doing here at the University of Bradford with Submerged Landscapes Research Center is here on this side of things, access to that commercial data is a thing, and companies are willing to let at least parts of the seismic profile, for example, be examined at certain shallow depths.
Hmm.
So a lot of the mapping that's been done in Cardigan Bay and Doggerland and whatnot has been from commercial data sets. It's been
Okay.
very, very useful. That kind of relationship is very important because rescue archaeology is not going to ever stop being a thing.
No,
And the
of course
more
not.
development moves onto the continental shelves, the more there's a need to understand how to do it.
Yeah, yeah, this makes a lot of sense. Yeah, and it also brings up the important tensions that exist between cultural heritage and, of course, commercial ventures. I meant to also bring up your article on the tropical cycle hurricane signatures and some of these shell middens that you found. And I found that to be amazing. I mean, you would think that a hurricane signature would just disperse a mound, but what are you actually identifying when you identify a hurricane signature? Is it having an impact on the sediments and their orientations or what?
It has an impact on the kind of sediments that get stripped out.
Okay.
So the bigger materials, even stuff as big as the microdebitage, generally does not get winnowed out by those waves and currents and storm tides. There is an impact. We did see it, but it's really a nuanced thing. And this was just pure dumb luck, having the opportunity to sample Econfina site after two different hurricanes. One of them was a pretty strong one. But having taken advantage of that, what we found was that the real fine fractions, right, the really tiny sands, stuff that's almost silt sized, tends to get pulled out. But the bigger materials are not really moving around that much. And
Interesting.
that is now was really happy to get that study done. There's another research group in the Tampa Bay area, Kendall Jackson and colleagues, who are finding that these shell midden deposits that they are documenting at wetland sites and in the coastlines themselves act almost like a kind of armoring
Okay.
that protects these coastlines, and that we need to start understanding that built environment, that pre-contact built environment, as including human alteration of the landscape, however intentional or unintentional it may have been, to protect against storm impacts. So raises a lot more questions than it answers, I think, about human behavior, but I think it bodes extremely well for preservation. And candidly, when we did that study, I did not expect those results. I did
Interesting.
not. I expected to see impacts. I did
Yeah,
not
I'm
expect to see
surprised as well, but
images. Yeah.
and it goes to show that yeah, the underwater can be a very protective environment for a variety of reasons in different locations.
Mhm.
Taphonomy there is just as complex as underground. That starts bringing up, I guess, sort of what we could end on, which is the relevance of this kind of research, thinking about how this is relevant in our world today. Do you have any thoughts on how this can inform us, either about just understanding different groups of people and how they live and their complexity, or about our own challenges with climate change and coastal sea level rise?
Broadly, the answer is yes, right? We are looking at people and their cultures. We're seeking for evidence of their lives at a time period when the climates and the coastlines were radically changing. So you imagine what it would have been like to have lived in a terminal Pleistocene into the Ice Age sort of situation, and to, without knowing it, realize that you had just seen the last mastodon that you'll ever see, right? We have entire species going extinct, all the big animals. You see a lot of ecological turnover. And because of the nature of the climate changes there, the Younger Dryas, for example, in Florida was a lot drier, but it wasn't colder,
Yeah,
right?
yeah,
So there's differential expressions of those kind of climate events. People got to eat.
yeah. I like to eat.
And same. They don't have a Tesco across the road from them like I do here in my flat in Bradford. And so when your climate starts getting upended and your food resources start getting relocated or eliminated, you have to figure out how to deal with that. And when I was doing the predictive modeling paper looking at early to middle Holocene transitions, one of the most interesting things that I found was that the best predictor for an archaeological site in that area of Florida was just the Osceola River. I mean, there's a lot of
Yeah,
other rivers there, but and part of that might be research bias. But I was working with data sets, big data sets, right? That's kind of reduced that level of error. And what it came down to, Flint, was that even through these horribly stressful climate episodes, these people persisted. They stayed where their ancestors had lived.
interesting.
They could have moved. They could have moved up the coastal plain into what is now middle Georgia, where the river systems were a lot more reliable. And the Osceola was and the rivers around it were practically going dry. But they didn't. They stayed where their people were from. And there is a lesson in that, because it doesn't take a lot of reading to see that people went back to the coast after Hurricane Ian.
Yeah,
I
yeah.
mean, it's a lot easier to move a foraging camp than it is I-75.
Yeah, it's actually really interesting because we oftentimes, I've seen a lot of comments on climate change and changes due to that in the past. And one of the big adaptations people always bring up is migration. But of course, that's not so easy to do in the lived experience. And so this is a great example of how people keep returning to where they're from and also living the life that they know how to live, which is coastal, right? These are people that have a lifestyle that is adapted to a coastal environment and the resources that are available there. You can't just go and
Yeah, I should.
be well adapted to
I'm
the middle
sorry.
of the forest.
Well, and I should note that the early Holocene people in that region were not, because of that very low gradient coastline, they weren't right up on the coast.
Hmm.
But there was pinniped phalange that turned up at a site called Sloth Hole, which is about a mile from the Gulf of Mexico,
Hmm.
where the Osceola meets the Gulf. And that dated to a period when the coastline would have been over 100 kilometers away. That thing didn't walk there by itself.
Yeah, people are
So,
bringing it in. Yeah.
yeah, that's published in Hemming's dissertation, from 2004, and that is a very strong hint that they at least visited the coastline and they understood things were happening down there. But even if the coastline wasn't overtaking their settlements in the middle of the night, it was still affecting the distribution of resources, and they were
Yeah.
still feeling the impacts of that. So yeah, they were feeling it, and they still stuck around. And I think that we see people do that today. And I hope that that engenders some compassion as we struggle to adapt to what's happening with our own experience of climate change. It's not simply that we have to adapt; it's that we need to perhaps be understanding of irrational, what we see as maybe irrational behavior in the face of that.
Yeah, I think that makes a lot of sense. And yeah, I mean, we have examples in Greece similarly of like Frankfurt Cave is this site that's occupied. It's right now on the coast. But when it was first occupied like 20,000 years ago, it was several kilometers away. And we can see adaptations and changes over time as the coastline gets much closer, as
Mhm.
people start engaging more with the coastal activities. But even before that, even when it was further away, we have clear examples of shellfish and other fish that end up in that cave and are brought there. It's just not as numerous, of course, until the coastline's much closer and they start doing intensive tuna
Right.
fishing. But yeah, there's clearly coastal engagement, and yeah, people stay there for tens of thousands of years. It's a struggle to think about that kind of thing. I mean, some of our oldest cities in the world that people live in today are only a few thousand years old maximum. People have been living at like Knossos on Crete for what, 5,000 years? That's nothing like 20,000 years in Frankfurt Cave of people going there.
Yeah, and that landscape would have had not just pragmatic meaning to the people that lived there, but there would have been entire belief systems that incorporated an understanding of their home landscape. What
Yeah.
that looked like, how that was expressed, really hard to say. The lived experience inevitably, I think, includes an awareness of that of landscape. I mean, much later and on land, look at the area around Newgrange, right? That's an entire Neolithic landscape that people lived in every day, where they were reminded of these religious things. And I
Mhm.
don't know why, although Newgrange and the area around it is pretty dramatic for the amount of terraforming that's happened. That same degree of emotional connection
Mhm.
certainly would have been at a place, present for the people living at Franch the Cave, people on the Paleo Oscilla, and people at Blinkerwall.
Yeah, exactly. There's a strong connection to the landscape. I mean, they live in it in a different way than we do as well. We're so used to change and new construction and whatever, moving around even
Mm.
more regularly. We don't have the same kind of connection to place that people in the past or other people that live a different kind of lifestyle have today as well. So yeah, very, very good points. Do you have anything else you want to share while I have you? You love underwater archaeology?
I would say that, hopefully what we're doing is contributing to a conversation that helps us appreciate, even when we see evidence that people persisted in places that maybe they should have left, right, due to climate change and whatnot. I would hope that it would help us understand people on a more empathetic basis, right,
Hmm.
and really give us an appreciation for that cultural diversity. I want to make another point too. The landscapes I work on in North America are indigenous landscapes, and that brings with it a degree of ethical responsibility. And
Yeah.
so, what we're hoping to advance, and this is a constant conversation, and I'll be talking about it a bit at SAA,
Hmm.
is not just Section 106 consultation, which is a flawed process in many ways, but hopefully, I'd like to build more towards collaborative work. And the University of Georgia has done this with terrestrial excavations
Hmm.
very successfully with the Muskogee Nation. But I'd like to see more active collaboration. David Robinson up in New England has done some very good work with indigenous nations there. I'd like to see more of that happen, because the stewardship of those landscapes really belongs in the hands of the people whose ancestors lived there.
Yeah, I could not
I'd
agree
like
more.
to continue Yeah, I'd like to continue to be allowed to explore and hopefully provide some knowledge. That'd be a nice thing to leave behind, but it's not where my ancestors are from. And I have that in the back of my mind every time I roll off a boat.
Yeah, I mean, I think there's this misconception sometimes because of some archaeologists that are still bad actors that want to avoid collaborating with descendant communities. But I mean, it's no different from me here in Greece. I mean, not in Greece right now, I'm in Cardiff, but when I work in Greece, I am collaborating with Greek archaeologists. I am doing everything under the auspices of the Greek government. And so everything I do is with absolute respect towards the heritage of ancient Greece as reflected
Mhm.
through the modern Greeks. And so I think that that's really important. And I think that archaeologists all over the world actually should be doing that. And in particular in America, there's a very troubled history. Of course, early archaeology was based off of grave robbing, destructions of mounds, things like this, without permission, without collaboration, without consultation, without any conversation. I think archaeology is always better when those collaborations and conversations are in place, and we need to work to regain trust, and to do things in an ethical way, that actually sort of
Absolutely.
helps out everybody. If you see what I mean, that's mutually beneficial for all.
Right. Exactly.
Yeah, so I think that's really important, and I think that's a great note to end on. So thank you so much, Jessica. It was absolutely fantastic, and I hope everybody has learned
Oh,
something.
well, the pleasure's been mine, Flint. Really appreciate the opportunity to talk with you today, and happy to always answer questions. And hopefully, I'll see you at SAA New Orleans in a month.
You'll see me there. All right.